Hello everyone, a very good morning and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year, first semester. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baripu. So you can personally meet me at college premises, ground floor physics lab. You can also send me a mail regarding your doubt and query on this topic in my given mail address, that is godphysics6@gmail.com and gopal.chakraborty_gkcem@jisgroup.org. Students, I have a YouTube channel, so I have already uploaded all the videos as per your State Council syllabus for this subject, Basic Physics. So you can go through that video, and if you feel any doubt, feel free to contact me at the given mail address. So for this subject, I am your subject teacher. Now the course pages are www.webscte.org and www.webscte.co.in. So the syllabus for this subject, Basic Physics, is already uploaded in the State Council website. So if you want, you can download the syllabus corresponding to first year, first semester curriculum from the web page as I mentioned here. So the subject title, that is Basic Physics, it is under the category of Basic Science course. It has a credit 3, 2 lecture per week and 2 practical per week. This course is generally made for diploma degree students of first year, first semester. So all the branches except architecture, photography, multimedia and printing technology, these, apart from these 4 departmental students, these rest of the departmental students have to study this subject, Basic Physics, as a part of their curriculum of first year, first semester. So as per our college, we have only electrical and electronics and communication department. So these 2 departmental students will have to study this Basic Physics in their first year, first semester syllabus. Now the topic that I will going to be discussing today's class, that is viscosity, Newton's formula for viscous force, coefficient of viscosity, Stokes Law and corresponding dimensional derivation also, terminal velocity, concept and formula only, and effect of temperature on viscosity, and some simple numerical problems. So these all the topics are under unit 2, that is general properties of matter, and it is the last part of the chapter, viscosity. So for this today's topic, the prerequisites are basic mathematics knowledge to solve the problems, knowledge of basic concepts science such as physics, visualization and analytical approach towards the subject is very much necessary. Now the course objectives are: learn about viscosity, effect of temperature on viscosity, and learn the uses of dimensional analysis to derive Stokes Law and its applications. So after completion of this topic, students will able to know viscosity and its applications, effect of temperature on viscosity. They will also able to calculate coefficient of viscosity, terminal velocity and force. So these are considered to be a possible course outcome. Now, as this is the last part of that topic, fluid mechanics, so students, those have missed the last two class that I have taken on that fluid mechanics, I have uploaded the video lectures in my YouTube channel. Please go through that video lessons once again, because the concept of that fluids and its properties are very much important for today's class. So in that class I have discussed about what is fluids, what are the corresponding properties, some Pascal's law, laws of flotations, Archimedes principle, buoyancy, and equation of continuity, and Bernoulli's principle. So these all things I have discussed in a detailed manner. So for today's class I will going to discuss the another properties of a fluid, that is viscosity. Now you see, all of you have seen that when say some water is flow through a drain, okay, so that water is completely or partially filled up with some mud or garbage like that, okay. So you see that when that water flows, the garbage or the mud that's a slowly fall in the lower part of the fluid or that liquid, and ultimately stored at the bottom of that drain, okay. You can also able to see that if you go through deep inside that flow motion liquid, or say when in case of a water, you can see that in a river, when the water is flow in a particular with a particular velocity, you will able to see from the outside that water is flow with a constant velocity. If you go in a deep, okay, if you swim and if you able to go inside that water, inside that river up to a certain depth, you see that in the lower part the velocity of that flowing water is very low, okay. It slowly gradually decrease, and at the lowest part at the bottom it almost comes to rest, okay. So due to that reason also, when some particle is carried by that by some fluid or liquid, okay, it ultimately stored at the bottom part, okay, because it not carried out throughout by that water or fluid, because the velocity of that water surface gradually decrease with increase of the depth. So now the question is, why this thing will happen? This thing will happen due to the presence of viscosity, viscous force, okay. So viscous force is nothing but dragging force, okay, frictional force between consecutive layers of that fluids. So due to the presence of that force, the lower surface of that fluid is actually drag the upper surface behind, okay. Upper surface always try to move in a forward direction as it has some velocity. Now lower surface, which is in contact with the upper one, there is a force of friction comes into act, as it is in try to in rest. So it actually drags the upper surface behind, okay. So this is happened due to the presence or existence of viscous force, and corresponding property by which it actually resists this kind of motion, this is called viscosity. So now I will discuss you what is viscosity, what are the corresponding property, and what will happen to that fluid in details. So now, what is viscosity? Viscosity is the property of fluid by virtue of which an internal force of friction comes into play when a fluid is in motion, and which oppose the relative motion between its different layers. The backward dragging force called viscous force or viscous drag. So here you can you able to see that in diagram I have shown you for a flowing water or some liquid which is flowing with some particular velocity, you can consider that a layer of water is flowing. Okay, so the lower surface just try to drag the upper surface in a opposite direction, opposite to the direction of motion of the upper surface. So due to which the lower surface moves in a with a lower velocity, and ultimately if you increase the depth, ultimately the last one is having the slowest velocity. So this thing will happen by this property of viscosity. And also some picture is given here. You able to see that water drops that flows or falls in a very first way, whereas the honey, when honey is fall down from some spoon, it's fall down in a slow manner, because the density is also play an important role for this viscosity. Now Newton's formula for viscous force and coefficient of viscosity. So how can you derive the corresponding Newton's formula, and how you will define the coefficient of viscosity? I will show you in detail. So here first see the diagram or figure. So suppose a liquid is flowing steadily in a form of a parallel layer of a fixed horizontal surface. So consider two layers capital P and Q at distance x and x plus dx from the solid surface, and moving with velocity v and v plus dv respectively. So then dv dx is the rate of change of velocity with distance in the direction of increasing distance, and is called velocity gradient. So here the upper surface having cross-sectional area A that try to move in a positive x direction, having velocity v plus dv, are at a height from the surface, solid surface, that is x plus dx, and the lower surface that again try to move in a positive x direction with having a velocity v, are at a distance x from the solid surface. Now according to Newton, a force of viscosity F acting tangentially between these two layers. So this force is proportional to the area of the layer of contact and proportional to the velocity gradient dv dx between two layers. So as you know, is the contact area is much more, so the frictional force will be much more. So here it is directly proportional. So from the second part you can write the force is directly proportional to the velocity gradient, so dv dx. So from here you can write F proportional to area into dv dx. So area, so that means combining these two, equation 1 and equation 2. So now in terms of equality you can write the force is equals to minus eta a dv dx. So F is the force, eta is the coefficient of viscosity, a is the cross sectional area, and dv dx is the velocity gradient. So now the negative sign shows that the viscous force act in a direction opposite to the direction of motion of that fluid. So it actually depends on the nature of the liquid and gives a measure of viscosity. So now if substitute the value of A1, that means unit cross sectional area, unit velocity gradient, so you can write that force is equals to eta. So hence the coefficient of viscosity of a liquid may be defined as the tangential viscous force required to maintain a unit velocity gradient between its two parallel layers, each of having unit area. Now this viscosity is actually depends on the change in temperature and change in pressure. So how it should change? So the effect of temperature and viscosity. So when a liquid is heated, the kinetic energy of its molecule increases and the intermolecular attraction become weaker. So hence the viscosity of a liquid decreases with increase in temperature. Sloth's imperial formula for the variation of viscosity of a liquid with temperature is eta, that's equals to eta at particular temperature, that's equals to eta naught whole divided by 1 plus alpha t plus beta t square. So where eta t and eta naught are the coefficient of viscosity at t degree C and 0 degree C respectively, alpha beta are the constant. Secondly, viscosity of gases is due to the diffusion of molecules from one moving layer to another, but the rate of diffusion of a gas is directly proportional to the square root of its absolute temperature. So viscosity of a gas increase with temperature can be written as N is directly proportional to under root capital T. Now effect of pressure. Except water, the viscosity of liquid increases with increase in pressure. In case of water, viscosity decreases with the increase in pressure for first few hundred atmospheric pressure. Secondly, the viscosity of gases is independent of pressure. Now a very important law which is basically on this viscous force, viscous dragging force, that is Stokes Law. So what is Stokes Law? According to Stokes Law, the backward viscous force acting on a small spherical body of spherical shape having radius r moving with a uniform velocity v through fluid of viscosity eta, that can be given by F equals to 6 pi eta rv. So where F is the viscous force or dragging force, eta is the coefficient of viscosity of that liquid, r is the radius of this ball, and v is the corresponding velocity. So this is Stokes Law. Now how we will derive this Stokes Law and corresponding expression? So here the easiest process is to consider the dimensional analysis. So by this dimensional analysis you can easily find out the expression for Stokes Law. So here that viscous force F is acting on the sphere moving with through that liquid, that may be depend on the coefficient of viscosity eta of that fluid, radius of r, that is a spherical body radius, and a velocity v of the body. So if you know that that force is depending on that quantity, so as per the dimensional analysis process, you can write F is directly proportional to eta, it is directly proportional to r, and directly proportional to v. Now the basic process is the same as per the dimensional analysis. So here you just write F is proportional to eta r v, and you don't know what will be the power of eta, what will be the power of r, what will be the power of v. So you consider F is proportional to eta to the power a, r to the power b, and v to the power c. So in terms of equality, you can write f is equals to k eta to the power a, r to the power b, and v to the power c. Now you substitute the dimension of each and every quantity, as k is a dimensionless constant. So here the f has a dimension mlt to the power minus 2. So in left hand side it is mlt to the power minus 2. In right hand side, eta that has dimension within square bracket ml to the power minus 1, t to the power minus 1, r radius that is l only, and the velocity that is lt to the power minus 1. So if you now substitute all the dimension in both left side and right hand side, and now equating the power of m, l and t, what you will get, you comparing the power of m, l, t, you get a value is equals to 1, minus a plus b plus c is equals to 1, and minus a minus c equals to 2. So solving these three will give you the a equals to b equals to c, that means all equals to 1. So which makes the formula corresponding to Stokes law, that is f equals to 6 pi eta rv. So for a small place k is found to be equal to 6 pi. Considering that, you can write f equals to 6 pi eta rv. So this is the expression of Stokes law. Now what is terminal velocity? So terminal velocity is the maximum velocity attainable by an object as it falls through a fluid. Here is the most common example. It occurs when the sum of drag force and the buoyancy is equal to that the downward force of gravity acting on the object. So since the net force on the object is 0, the object has a 0 acceleration also. In fluid dynamics, as object is moving at its terminal velocity, if its speed is constant due to the restraining force exerted by the fluid through which it is moving. So here to find out the expression of a terminal velocity, you can write that terminal velocity v equals to 2 by 9 r square within bracket rho minus sigma into g whole divided by eta. So this is the expression of terminal velocity. So okay, these are the theory part from this portion, and now I will show you some simple numerical on that force, dragging force, or on the Stokes law. Okay, so if you solve if you practice this kind of a problem, it will be very much helpful for you to understand this chapter. Now the first problem, a metal plate 5 cm into 5 cm rests on a layer of castor oil 1 mm thick, whose coefficient of viscosity is 1.55 Newton per meter square. So find the horizontal force required to move the plate with a speed of 2 cm per second. So here as you know, the given quantities are cross-sectional area A, that is 25 cm square. So that means 25 into 10 to the power minus 4 meter square. Dx that is equals to 1 mm, that means 10 to the power minus 3 meter. Eta that is 1.55 Newton per meter square, and dV equals to 2 into 10 to the power minus 2 meter per second. So as you know, the viscous force or dragging force, that can be written as F equals to eta A dV dx. So if you substitute all the value, what you will get, 1.55 into 25 into 10 to the power minus 4 into 2 into 10 to the power minus 2 whole divided by 1 into 10 to the power minus 3. So ultimately gives you 0.0775 Newton. Now the next problem, that is a square metal plate of 10 centimeter side moves parallel to another plate with a velocity of 10 centimeter per second. Both plate immerse in water if the viscous force is 200 dyne and viscosity of water is 0.01 poise. What is their distance apart? So here the cross sectional area is given 10 into 10, that means 100 centimeters square. Eta, that is 0.01 poise. F is equals to 200 dyne and dV equals to 10 centimeter per second. So as you know, as per Newton's formula, the viscous force or dragging force that can be written as that force equals to eta into A dV dx. So dx is equals to eta into A into dV by F. So substituting now all the value, that is 0.01 into 100 into 10 whole divided by 200. So that actually makes the dx value 0.05 centimeter. So this is the required distance. Next problem. The velocity of water in a river is 180 km per hour near the surface. If the river is 5 meter deep, find out the shearing stress between horizontal layers of water. Coefficient of viscosity of water, that is given 10 to the power minus 2 poise. So as the velocity of water at the bottom of the river is 0, so dV is equals to 18 km per hour, that means equals to 18 into 5 by 18, that is 5 meter per second. Also the dx value, that's equals to 5 millimeter equals to so eta equals to 10 to the power minus 2 poise, that means 10 to the power minus 3 Pascal second. For the viscosity, as per Newton's formula, you can write F equals to eta A dV dx. So single stress, that means single stress, that will be F by A, force per unit area, that's equals to eta into dV dx, that's equals to 10 to the power minus 3 into 5 by 5, that means 10 to the power minus 3 Newton per meter square. Next problem. In giving a patient a blood transfusion, the bottle is set up so that the level of the blood is 1.3 meter above the needle, which has an internal diameter of 0.36 and is 3 centimeter in the length. If 4.5 centimeter cube of blood vessels blood passes through the needle in 1 minute, so calculate the viscosity of the fluid. The density of the liquid, that is 1020 kg per meter cube. Now length of the needle, that is L equals to 3 centimeter, and radius of the needle, that is R equals to 0.36 by 2, that means 0.018 centimeter. Volume of the blood flowing out per second, that is Q, that's equals to 4.5 by 60, that means 0.075 centimeter cube per second. Now density of blood, that means rho is equals to 1020 kg per meter cube, that's equals to 1.02 gram per centimeter cube. So that's equals to pressure difference, so that means P equals to 1.3 into 100 into 1.02 into 980 dyne per centimeter square. So ultimately gives you eta is equals to pi p to the power 4 by 8 pi. So substituting all this value, you get the eta value is 0.238 poise. Now these are the possible books as you can refer. Now the evaluation process is same. You have to appear for a 70 marks end semester exam, 20 marks mid semester exam, and rest 10 marks for attendance, interaction and assignment. So with this class I have completed the chapter fluid mechanics and that part viscosity. So hope all of you have enjoyed and understand. So if you feel any doubt, feel free to contact me. So thank you.